good morning, my dear students. How are you all? Hello, everyone. So, how is everyone? How is your preparation going? Are you prepared for your exams? Hello, everyone. Okay. Hello, Yadav. So, in this video, in this live, we will be discussing this first sample paper 1, that is the sample paper for the year 2025-26 session, right? Good morning. Let me just refresh it and then yeah. Good morning, Fahim. Okay. Fahim, don't worry. From today onwards, if you have not studied, you still have time, and do not lose it first of all, and try to, you have 4 chapters, right? So start with the important chapters, metals, non-metals and carbon and its compounds. Then there are certain topics that are very important from that chapter. From metals, non-metals, you have that process, extraction of ores is very important. Then you have the chemical reaction of metals, that is very important. From carbon and its compounds, the chemical properties of ethanol, ethanoic acid, esterification, saponification, these reactions are very important. Then you have nomenclature and test for ethanol and ethanoic acid. These are very important, so focus on these. And hello everyone. Yep, so prioritize the important topics, work smartly, okay, now that you have very less time, and try to solve previous year questions for the last 5 to 10 years, last 5 years sample paper and last 10 years PYQs. That will do, and you will score good if you follow these steps. Important topics, prioritize important topics, solve questions, NCERT, PYQs, right? 5 years PYQ, 5 years sample paper and 10 years PYQs, and yeah, the rest all will be good. And third is revision, revise, okay? Finish it all and then revise. Okay. Good morning, Sharma ji. So let's start with the official sample paper of CBSE, and yep. So Tabina, that depends what kind of issues are you facing when you are solving the sample papers. Do tell me, as in you are not able to understand the question, or you're not able to write the answer correctly, or is there any knowledge gap? Whatever you are reading, you're not getting the questions from there. What is your problem? Firstly, identify it and then try to work on it step by step. Hi. Okay. If you're new, welcome here. And okay, let's start. Let's start with the 1 marker questions. Firstly, the 1 marker questions. Okay, the question is, which of the following equations represent redox reactions and what are the values of P and Q in these reactions? So you are given 2 reactions, equation 1 and equation 2. Okay, you need to tell me firstly which of these is a redox reaction. Now what is a redox reaction, ma'am? A redox reaction is a reaction in which both reduction and oxidation happen, right? Yes, there was a class at 8 AM about assertion and reason questions. I hope you attended that. 30 sample paper given by my school. So should I solve any other book? So sample paper, Sanic, right? So you should do one thing. If you have solved 30 sample papers, so try to solve 5 previous year sample papers given by CBSE. It is on their official website, or you can download it from any other website. Solve these last 5 years sample papers by CBSE and majorly focus on the PYQs. Okay, PYQs are like a blueprint for your upcoming exam. The pattern has changed, I know, but it is kind of similar. Instead of being questions this like you have one bio, one physics, one chemistry question, they have kind of separated everything. So you have section A, section B, section C. Only this thing is different, plus that there's one thing, competency based questions. Just if you do that, the PYQs and the sample paper, everything will be covered. Plus you have good conception knowledge, that is you understand your syllabus. That is more than enough. Okay, let's start. Which of the following equation represent a redox reaction? Again, where reduction and oxidation is happening, right? We are looking for reduction and oxidation. Now see, ferric oxide is getting converted into iron, aluminum is getting converted into aluminum oxide. So that means oxidation of aluminum is happening, right? Oxidation of aluminum is happening, and iron oxide is getting converted into iron. That means there is loss of oxygen. Loss of oxygen means reduction. So this process is reduction and this process is oxidation. So that means equation 1 is redox reaction. That is correct. Now let's move on to the second reaction. Carbon. This is a carbon compound. It is getting converted into, let me change the color real quick. Okay. Carbon is getting converted into carbon dioxide and oxygen is getting converted into water. So oxygen to water, that means yes, oxygen to water, that means there is addition of hydrogen. And if there is addition of hydrogen, that means it is reduction, my dear students. Yes, it is reduction. So this is reduction, and there is addition of oxygen to carbon. There is addition of oxygen to carbon. So that means this is oxidation. Again, if in a reaction both oxidation and reduction happen, that means it is a redox reaction, my dear students. So both of these are redox reactions. Now you need to find the value of P and Q. So let me clear it for you. Where is the P and Q? Here is the P and here is the Q, right? So see, on the left hand side you have 2 iron. On the reactant side you have 2 iron. That means the value of P will be 2, because we need to balance the reactants, the number of atoms on both sides, on the reactant and on the product side. So if there are 2 irons on the reactant side, there will be 2 irons on the product side. Now let's move on to the Q. Okay, how many hydrogens are there on the left hand side? Let's count it. 10. There is a 2. 10 times 2 means 20. There are 20 hydrogens on the reactant side. So how many hydrogens you need on the product side? You need 20 hydrogens. Clear? 20 hydrogens you need, right? We have already 2 hydrogens. So what do we multiply it with? 10, right? We'll multiply it with 10, because 10 times 2 is equals to 20. So that means Q will be equals to 10 and P is equal to 2. And both of these reactions are redox reaction. So both equation 1 and 2 are redox reaction. Which option matches it? Both equation 1 and 2 are redox reaction, and P is equals to 2 and Q equals to 10 and Q equals to 10. Yes, the correct answer is option number D. So if you all have solved the sample papers, you might have solved this sample paper also, right? Hello Anju. Hi Aryan. Yes. Okay. Science paper is tough now, 2026 science paper. Okay, so Tabina, I believe. See, the paper is from moderate to difficult level. The paper will be from moderate to difficult level, okay? And so prepare accordingly. The level is a little bit higher because of these competency based questions. And yeah, so do not worry. If you have studied it well, you will be able to solve all the questions. Little bit, yeah, it is little bit tougher. Yes, only little bit. Next question. 4 statements about the reaction of oxides with dilute hydrochloric acid and aqueous sodium hydroxide. So one is acid and the other is base. So how does metals, oxides actually react with acid or base? Okay, you need to know. First of all, we'll start with the first statement. Aluminum oxide. What is aluminum oxide? It is metallic oxide. No, it is amphoteric oxide. Aluminum oxide is amphoteric oxide. And what do you mean by amphoteric oxide, ma'am? Amphoteric oxides are those oxides which react with both acids and bases. So aluminum oxide is an amphoteric oxide, right? That means it reacts with both dilute hydrochloric acid and sodium hydroxide. So this statement is correct. Next statement. Calcium oxide reacts with dilute hydrochloric acid and aqueous sodium hydroxide. Now see, calcium hydroxide, this is a metallic oxide. Right? And metallic oxide only react with acids. Okay? So this statement is not correct. Next is zinc oxide reacts with both dilute hydrochloric acid and aqueous sodium hydroxide. So we have 3: zinc, aluminum and lead. These 3 metals form amphoteric oxides. Always remember it. These 3 metals always form amphoteric oxide. Okay, so zinc oxide, yes, if it is an amphoteric oxide, it will react with both acids and bases. Yes, acids and bases. So that means this statement is also correct. C is not incorrect. Okay, acha. Sulfur dioxide does not react with either dilute hydrochloric acid or aqueous sodium hydroxide. Sulfur dioxide, SO2, sulfur dioxide. This is acidic oxide. It is a non-metallic oxide. Non-metallic oxides are acidic in nature. If it is an acidic oxide, will it react with base? Yes, an acidic oxide will react with the base, but here it is written it does not react with either of the following, either dilute hydrochloric acid or aqueous sodium hydroxide. Yes, so that means the correct answer is you have only 1 and 3, which is correct. Question is, which of the following statements are correct? So the correct statements are option 1 and option 3. Why are you answering A? Somebody answered A, right? No, B. Yes, the correct answer is B. Nikhil, the correct answer is B, not A. Hi, Neha. Okay, next question. Which of the following substances, when dissolved in equal volume of water, will have the highest pH? What do you mean by highest pH? We have pH scale from 0 to 14, right? And highest pH mean the substance is basic. Highest pH means the substance is basic. Now, which among the following has the highest pH? Which among the following has the highest pH? Because water is neutral. Water is around neutral, okay? So if you add anything that has a higher pH, so that will increase the overall pH, right? That will increase the overall pH. So that means this is an acid. It has lower pH, less than 7. Acidic acid, again acid. Magnesium hydroxide and sodium hydroxide. In between these, which has higher basicity, or which is more basic? Sodium hydroxide, right? Sodium hydroxide is a very strong base. Sodium hydroxide. It has a pH value of around 14. So that means among the following, the substance that you will add to increase that will have the highest pH value is sodium hydroxide. Is sodium hydroxide. D, correct. Everyone is answering D, correct answer. Next question. Methyl orange is added to, these all are 1 marker questions, my dear students, okay? These all are 1 marker questions. Methyl orange is added to dilute hydrochloric acid and to aqueous sodium hydroxide, right? Methyl orange, it is an indicator. So you need to tell me the color change. When methyl orange is added to, yes, D is the correct answer. Yes. For this one, not for this one, the previous one. So when you add methyl orange in acid, or in base, so when we add methyl orange in acid, the color change is, yes, the color is red. We have two options. Either it will be B or it will be C. Now let's see. In basic medium, what is the color of methyl orange? Yes, it is yellow, my dear kids. It is yellow. Yes, so that means C is not the correct answer. B is the correct answer. The correct answer is B. Yes, B. Not C is not the correct answer, Nikhil. B is the correct answer. Yes. Not C, B. Yes. B is the correct answer, because methyl orange in acidic medium gives red color and in basic medium it gives yellow color. Yes. Next question. When excess of carbon dioxide is passed through lime water, the milkiness disappears. So you should always know the reaction actually. This is lime water. This is lime water, right? And when you add carbon dioxide, when you pass carbon dioxide gas through lime water, we get calcium carbonate, right? This is milky. This is the reason of milkiness, right? Now after this, if you pass too much, there will be water also. If you pass too much carbon dioxide gas, what will happen? This will get converted into this one, calcium hydrogen carbonate. Now this calcium hydrogen carbonate is water soluble. Calcium hydrogen carbonate is water soluble. The milkiness disappeared because the water insoluble calcium carbonate converted to water soluble calcium bicarbonate. Yes. Hi everyone. Yes, the correct answer is B. The correct answer is B. Let me see what doubts you have. Yes, calcium carbonate. Okay, chemistry. So no. Regarding the that formula, if you have the pH formula, right? Negative logarithm of H positive, that is not in your syllabus. It is not coming in your 10th class CBSE board. It is coming in 11th class, not in the 10th class. So do not worry, no question will come from this. And if you find chemistry really hard, follow me. I am helping you. I will try to help as much as you can, as I can actually. And whatever doubt you have, come with me. I'll try to answer it. And yeah, do not worry first of all. Do not stress it out. Yes, A, C, D is incorrect. Correct. Next question. In the reaction of aqueous solution of barium chloride with aqueous solution of sodium sulfate. So the reaction is barium chloride on reaction with sodium sulfate. What do we get? Barium sulfate plus sodium chloride. Barium sulfate plus sodium chloride. This is the reaction. The question is, the aqueous solution formed will be, which among these is the part of aqueous solution and which is not the part of aqueous solution. So we have two things here. Barium sulfate is precipitate, right? Or you can say PPT, precipitate, right? It is a white precipitate of barium sulfate. Sodium chloride is a part of aqueous solution. It will be the soluble part. And this is the insoluble part. Clear? The insoluble part is barium sulfate and the soluble part is sodium chloride. So the correct answer is option number D. Yes, the correct answer is option number D. Option D. The aqueous solution will be of sodium chloride. Next question. Yes, correct answer is option number D. Yes. Yeah, it has been, the last question was repeated multiple times. Yes. The question is, an iron nail is added to each of the two test tubes, P and Q. You have two test tubes. Let me draw it, P and Q. Containing copper sulfate. This one has copper sulfate and the other has silver nitrate. Which of the following observation is correct? So firstly, you should know an iron nail is added. So this is iron nail, Fe, right? So you should know which is the one, yeah, getting reacted. C, D. Some are answering D, some are answering C. B is also there. Let's see. In test tube P, iron nail is coated with a blue coating, and in test tube Q, there is no reaction. So first of all, we are talking about silver nitrate and copper sulfate. Iron is more reactive than both, right? In the reactivity series, iron is more reactive than both copper and silver. So that means a reaction will happen. There will be some coating. You just need to figure out the color of that coating. A is not the correct answer because according to A, in Q there will be no reaction. That is not correct. Second is iron nail is coated with brown coating in test tube P and silver coating in test tube Q. So yes, that is correct. Why? Because copper, the coating of copper is reddish brown in color, right? And silver, again, silver has a, again it has a silver color, right? So that means the correct answer is option number B, not C. Again, correct answer is option number B. There is no reaction, that is not true, because there is a reaction, then there is no reaction test tube P, but there is a reaction test tube Q. That is also incorrect because iron is much more reactive than both copper and silver. A reaction will happen in both, but you need to figure out the color. The deposition will be of copper in first case, and in second case it is silver, right? So the color you should know, copper is reddish brown in color and silver is silver in color. Okay. Next question. Which topic you want me to explain? Just answer, just tell me which topic you want me to explain. Next question. Assertion says C4H8, C4H6, C4H10 are members of the same homologous series. Okay. Firstly, are these the same members? No, they are not. This is alkene. This is alkyne. And this is alkane. So no ma'am, they are not the same member of they are not belonging to the same homologous series. They do not belong to the same homologous series. So that is incorrect. So that means it is incorrect. Now the reason is they are unsaturated hydrocarbons. So among these C4H8, C4H6, C3H4, yes, these are alkenes and alkynes. These all are alkenes and alkynes. So yes, these alkenes and alkynes are unsaturated hydrocarbons and alkanes are saturated hydrocarbons. So reason is true, but the assertion is false. Reason is true, but the assertion is false. How can you say both are correct? No, that is incorrect, Nikhil. So you want me to explain the reactivity series? Let me explain. I'll explain it. Wait. So the correct answer is option number D. Yes. Correct answer is option number D. Assertion is false, but the reason is true. Why? Because these are not the member of the same homologous series. They all belong to different homologous series. Alkene, alkyne, alkane, right? These all are different homologous series. Question 7. So in question 7, we had the reactivity series. We used the reactivity series. Okay, this is the reactivity series. If we start from, I have a mnemonics actually. Please stop calling me a careless zebra. Instead, try learning how copper saves gold, platinum. Okay, please means potassium. Please means potassium. Stop means sodium. Calling means calcium. Me means magnesium. A means aluminum. Then there is careless means carbon. Zebra means zinc. Instead means iron. Try means tin. Learning means lead. How means hydrogen. Copper. Saves means silver. And gold means AU. And platinum again platinum, PT. Okay, so this is the reactivity series. This is the decreasing order of reactivity series. What is happening when you go down the reactivity series? The reactivity for all the metals decreases. Okay, any metal lying above any other metal. Let's see, if you are talking about, let's say, calcium and aluminum. As calcium is lying above aluminum in the reactivity series, that means calcium is more reactive than aluminum. Simple. Similarly, let's compare aluminum and iron. As aluminum is lying above iron in the reactivity series, it is much more reactive than iron. Okay, where is this concept used? It is used to determine the displacement product, the displacement reaction product. Okay, so if any element is much more reactive than the other element, it will displace that element from its compound. Okay, for example, in between calcium and aluminum, calcium is much more reactive. It will displace aluminum from its compound. Similarly, in between, let's say, sodium and zinc. Sodium is much more reactive. It will displace zinc from its compound. Okay. Hello, Govardhan. Hi, Nobita. I hope it explains your doubt. Okay. Next question. 2 markers. We are done with the 1 marker question. Now let's start with the 2 marker questions. First question is, the following activity set up in the science lab by the teacher. He clamped an aluminum wire. This is the aluminum wire. Okay, and fixed a pin to the free end of the wire. So if you can see it properly, I believe, there is this pin. This is a metal pin. Okay. And then he heated the wire with a burner from the end where the wire is clamped. So here he started heating this metal wire. Firstly, this is an aluminum wire, right? Then there is a nail pin to it using wax. Wax is there, okay? And then he heated this metal wire, this aluminum wire, okay? Student observed the pin fall off. The pin fall off. So if the teacher replaced aluminum by silver wire, will the students observe the change? Will the students observe change? Do you think the students will observe the change? What if copper do not save gold? So copper did save gold, okay? Because only then you see the reactivity series, as there is no element. You can learn it that way also. Yes, that is also a one way to that is also one way to memorize it. As far as you have in mnemonics, do not concern much. Any mnemonic here, that will work if you remember it. It should help in your exam. Yes. So if we change it, what will happen? And then will the aluminum wire melt? Give the reason for your answer. Answer the question. So if I replace aluminum by silver wire, will there be any change in observation? Will there be any change in observation? So hello everyone, what are you answering? Silver wire will melt because it has low melting point. Okay, you scored 18 science, congratulations. Aluminum is more reactive than silver. Yes, it is more reactive than silver, but what will be the observation change? If you heat it, will it heat more quickly? Yes, it will heat more quickly. Aluminum is a high melting point, so it will not melt. Yes, it will not melt. Yes, what doubt you have, Tabina? Tabina Sheen. What doubt you have? Tell me your doubt. Let me answer your doubt first. Yes, aluminum will not melt. Yes. Yes, what is your doubt, Tabina? Hi, Ryan. Good. Okay, so if the teacher replaced aluminum wire by silver wire, heating will be fast. Heating will be fast. Okay, this pin will drop off much more quickly than in case of aluminum, right? Also, the melting point is low, so the wire will start melting if you heat it for a long time. Yeah, she's typing her doubt. I know. You are not able to recognize the question. Is it not visible to you all? Are you not able to recognize the question? Is it not visible? Is it not clearly visible on your screens? Quickly tell me, everyone, is the question not visible? Let's not just this diagram. I'm asking the words. Are they not visible or are they clearly visible? Tell me. If they are clearly visible, please say clearly visible, ma'am. Hi, Natik. They are clearly visible. Okay, I am taking it they are clearly visible. Will the aluminum wire melt? No, it will not melt. As aluminum has higher melting point than silver. Okay, it is visible, but the figure is not. No worries, the figure I have explained it to you. Okay, it is just in wire clipped to a clamp stand, and here it is a burning lamp, spirit lamp, and in the end we have pinned wax. Using wax we have attached a pin. Okay, next question. Only 1 2 marker question was there. Okay, let's start with the 3 marker questions. Attempt either A or B. So you need to attempt either A or B. Like mostly it is the sample paper that I've taken from the CBSE's website. Okay, so I'm solving each and every question, but in the exam, if you are given the choice, always attempt one question that you are very sure of, because the examiner will not look at the second answer even if you attempted it correctly. Okay, an element X is stored in kerosene and cannot be extracted from its ore using a reducing agent. X forms an ionic compound on reaction with chlorine. Can we store X in water? Give reason to support your answer. No, we cannot store X in water. Firstly, we all know that this X is what? Sodium. This X is sodium. Okay. Can we store X in water? No, we cannot store X in water because it reacts exothermally. Highly exothermic reaction, right? Violently, vigorously you can say, with water and forms sodium hydroxide. Clear? So that's why we cannot store it in water. Why? Because it reacts vigorously with water. And why do we store it in kerosene? Because when you store it in kerosene, it cuts off the oxygen supply. And due to that, it won't combust. Okay, it actually has this explosive power stored inside it. So whenever you put it in water, it explodes. There's so much heat release that it looks like an explosion. Okay, hold on a second. You have the doubt, ma'am. Silver will melt, right? I just joined now. Okay, yes, silver will melt, but we were talking about aluminum. X is sodium, correct? No sodium reaction is highly exothermic. Yes, correct. Nobita reacts vigorously. Yeah, that is the sound effect. Then you have, where is your doubt? I'm still looking for your doubt. Highly exothermic. Yes. Thank you. But why, ma'am, it shows? Shows what? Diwali only. No, not Diwali. What, Zaira? What does it show? Okay. So, next question. Identify the element X. So, we have identified it. It is sodium. We have collectively identified it. Name the process used and write the equation for the extraction of X from its ore. The process is called Downs process. Yes, the process is called Downs process. And there is one more name for this Downs process. What do we call it? Yes, there is one more name for the Downs process. What do we call it? We call it electrolytic reduction. Electrolytic reduction. So what we do exactly, we take a brine, aqueous solution, sodium chloride, right, and we pass electricity through it. We have an anode, we have a cathode, right, and we pass electricity through it. So what will happen at the anode, what do you get at the anode and what do you get at the cathode? At anode we get chlorine gas, right? At cathode we get sodium, right? We have an anode, we have a cathode, we pass the electricity through it, through the sodium chloride solution, molten sodium chloride solution, right? Molten sodium chloride, yes, electrolytic reduction. Therefore, yes, it is the name of that process. I have never seen. So, in place of Down process, you use the word electrolytic reduction. Yes, it reacts vigorously, correct. Yes, NaCl gives Na and Cl, not Cl, Na and Cl2, Cl2. Because Cl alone can't, so 2Cl molecule will combine and we get Cl2. Okay, electrolytic reduction is important. Electrolytic reduction and electrolytic refining, okay? Do study them well. Next question. The domes of many buildings in Europe are made of copper, okay? Any one of you visited Europe? I have not, so if you have, do share the details though. These domes now appear greenish in color. Now, if you have visited it, so you might have seen it, but because I have not, I've seen the pictures. So there it appears little green. It actually appears not little, it appears greenish in color, okay? So why do the domes appear greenish though copper is orange red? Because at the time when they were made, freshly made, okay, newly built, so they were all orange reddish in color. Those buildings were orange reddish brown color, okay? It was very pretty. Paris, you have visited Paris. That is very nice. It is very beautiful. I have heard of, okay? Yeah, same. Okay, so what happens? The greenish color is due to what? Because the copper is reddish brown, right? But why do the buildings start appearing greenish after some time? So the reason is that copper, it combines with the oxygen present in the atmosphere, gets converted into copper oxide, right? And this copper oxide, when exposed to too much carbon dioxide, too much emissions are there, right? Vehicles are there, everything. We are breathing carbon dioxide, right? So this carbon dioxide, the copper oxide combines with the carbon dioxide and we get copper carbonate. Now this copper carbonate, this is the greenish thing. This is the greenish thing. This is the greenish thing, okay? The reason is because copper gets oxidized due to the action of carbon dioxide, gets converted into copper carbonate, which is the reason of green color. Okay. Ma'am, could you please explain? Okay, electrolytic reduction. I'll explain it after this question. Is it okay? Let me finish the question first. Yes, it reacts with oxygen. Okay. Next is, in your opinion, should the copper domes be replaced by iron domes to overcome the problem of change of color of copper domes? So yes, that could be one approach we can think of, but no. Why? Because what happens is, when you will replace copper with iron, as copper is much more reactive than iron is much more reactive than copper, it will undergo corrosion. So now it is appearing greenish, but then it will literally corrode. It will fall off, right? Rusting of iron, right? You have heard it. So iron gets corroded very easily than copper. Why? Because iron is much more reactive than copper, and because of that reason, no, we cannot replace the copper dome with iron. One more question I have, actually, it is about India. So in India, there is one pillar we have. What is the name of that pillar that never rusts, and where is the location of it? It's a good question, I believe. Europe. Yeah, sure. Me too. Iron will start to rust. Okay, take care. Health is much more important. Your exams are coming, so be physically well so that you can prepare for your exams. Hello, Harshit. Okay. So yes, that is the answer. Because iron will get corroded. Domes used to be made from thin sheets of metals. Why did the ancient architects use copper to make domes? Because thin sheet of metal. The answer is in the question itself, my dear kids. See, thin sheets means the property that is used to make thin sheet is called malleability, right? The property is called malleability. As copper is highly malleable. Copper is highly malleable. That is, it can be beaten down into thin sheets, and because of this property it was used by the ancient architects to make domes, because then you can beat it. Domes has this structure, right, like this. I am really bad at drawing. Let me try again. These structures, like these are domes, right? Very bad dome, looks like a UFO, but yes, iron pillar at Delhi. Yes. So what is the name of that pillar? Tell me the name. Because it is highly malleable, that is, it can be beaten down into thin sheets, and when you arrange these thin sheets in place in shape like domes, you got those beautiful buildings that are there in Europe. Okay. Yeah, hemisphere. Yeah, it looks like a hemisphere, not a dome exactly. Okay, so electrolytic reduction. Let me have some space here. I'll explain the electrolytic reduction. Okay, so we have an anode, then a cathode, and both are connected to a source of electricity. Anode is positively charged, cathode is negatively charged. Then we have a Na sodium chloride solution, molten sodium chloride actually. So what happens when you pass electricity through it? What will happen? When you pass electricity through it, my dear kids, NaCl will break down as Na and Cl2, right? That is the simpler explanation. Let's not complicate it, right? When NaCl breaks down, it breaks down at Na and Cl, right? Cl will combine with other Cl and we'll get the chlorine gas, right? So in here, at the anode, because anode is positive and Cl, actually the reaction is like this actually. We get Na positive and Cl negative. Okay, we get Na positive and Cl negative. So you can see the sodium will go to the cathode, and at anode chlorine gas will be evolved at anode. Okay, chlorine gas will be evolved at anode, and the sodium will get at cathode. Clear? What do you want me to explain? Please tell me. That is different. Always, please listen carefully. This is electrolytic reduction. This method is used for separation or electrolytic reduction. It is used for really highly active reactive metals. This method, electrolytic reduction, is used to get metals which are highly reactive, which are present in the form of their molten chlorides, right? Then electrolytic refining. This is for metals ranging from medium to low reactivity. Refining means we already have the impure metal, we just want to get the pure metal. Here it is the metal ore we have. From the metal ore we are getting the pure metal, we are getting the metal. Clear? There we are refining, here we are getting the metal, right? Yeah, that is electrolytic refining. No, not this question. I am explaining electrolytic reduction. So when you pass electricity through it, at the anode we get the chlorine gas, at the cathode we get the sodium, right? That's how you do the electrolytic reduction. When you pass electricity, breaks down to Na positive, Cl negative. Anode is positive, that's why negative ions will go. That means chlorine will come here. And cathode is positive. Cathode is negative. That means positive ion will come to it, which means sodium will come to this one. Okay. Yes, I hope it is clear. Let's start with the, yes, we did this question, right? Moving on to the next question. The question is Amrita electrolyzed distilled water using the setup. Again, if you cannot see it, do not worry, I'll explain it. She had this beaker, okay, one is anode, one is cathode. This one is anode, the one on the left side is anode, and the one on the right side is cathode. The process is electrolysis of water. The process is electrolysis of water. So she electrolyzed it. She was expecting two gases to be evolved at the anode and cathode respectively. Suddenly she realized that the bulb in the circuit did not glow when she used distilled water. When she used distilled water, why did the bulb not glow when she used distilled water? Tell me the answer. I will explain electrolytic refining at the end of the session, okay? Right now, I have done the electrolytic reduction. We need to focus on the questions first. Do not worry, I'll explain the electrolytic refining. And please stop spamming about electrolytic refining. I will remember it. Stay till the end of the class, I'll explain it. Okay. Any equations in this reaction? I believe you're asking. So the equation is NaCl gets broken down into Na. This is the reaction. Balance it. Clear? Because of absence of ions, because there are no ions, yes, because it is the pure form of water. No, it is not the pure form of water. It is, but the reason is, yeah, there are no ions. Distilled water is not it does not pass the electricity because it does not have ions, because there are no minerals, there are no ions in distilled water. Yeah, because of that reason the bulb did not glow, right? Clear. Okay, one more thing. What kind of water we use when we are doing the electrolysis of water? What kind of water we use then? If not distilled water, then what kind of water we use? After this realization, she added a substance to the distilled water for electrolysis to take place. Okay. Answer the following question. So firstly, which gases she was expecting? Tell me one thing, what kind? If not distilled water, then what kind of water we use? Yes, there are no free ions, there are no ions. Yes, correct. Minerals, ions, ashes should be added. Yes. The thing that should be added to the water is acid. Any acid, any dilute acid you add, because acids have ions, H positive ions, and these ions will conduct electricity. So the substance that is added is an acid. That's why we use acidified water, not distilled water. We use acidified water. What do we use? Acidified water. So which gas was she expecting? Now tell me, if you do electrolysis of water, which is this one, what do you get at anode and what do you get at cathode, my dear students? What do you get at anode and what do you get at cathode? Tap water. Yeah, tap water. Acid should be added. Tap water does have ions, but when you're doing electrolysis, when you want to get hydrogen and oxygen gas, we use acidified water. Yes, we use acidified water. So at anode, what do we get? Yes, at anode we get oxygen and at cathode we get hydrogen. Yes, at anode we get oxygen and at cathode we get hydrogen. Clear? Why did the bulb not glow when Amrita passed? Because Amrita passed electricity through distilled water because there were no ions. Because there were no ions to conduct electricity. Because there were no ions to conduct that electricity in distilled water. Which substance was added by Amrita to distilled water to get the expected result? An acid. Name an acid. Any acid. Let's say she added sulfuric acid. Any acid. Any acid will do. She added, let's say she added sulfuric acid. Okay. Yes, at anode oxygen, cathode hydrogen. Cathode hydrogen, anode oxygen. Yes, everybody is answering correctly. Yes. Good. Next question. Actually, you can remember it. Anode have an oxygen, right? Oxygen, anode, OO. Then hydrogen, cathode. There is an H in cathode. H, hydrogen, cathode. Yes, HCl, H2SO4, anything you can add. Yes. Done. Next question. Identify the type of reactions. Identify the type of reaction. So, what is the name of these reactions? Yes, 2:1, Sharma ji, correct. So, what is the name of these reactions? When zinc oxide combines with carbon, yes, we get zinc plus carbon monoxide. So what kind of reaction is this? Zinc oxide is getting converted into zinc. Carbon is getting converted into carbon monoxide. So there is removal of oxygen. Removal of oxygen means, yes, removal of oxygen means reduction. And there is addition of oxygen also. Carbon is adding oxygen and we get carbon monoxide. So that is oxidation. Clear? So that means the reaction A is redox reaction. The second reaction, zinc carbonate. Yes. Yeah, you're answering in a very good sequence actually. Yes, reduction, oxidation, also redox, done. First is redox. Everyone is clear. Second is zinc carbonate breaks down into zinc oxide plus carbon dioxide. What kind of reaction is it? Doesn't it look like one reactant break down into two or more products? Yes, that is a decomposition reaction. Next is magnesium combines with oxygen. We get magnesium oxide plus heat. Magnesium oxide plus heat. What is it? This is, it's multiple reaction. We have combination happening. This is a combination reaction. Then oxidation is also happening, right? Oxidation. Then heat is getting released. Heat is getting released means exothermic. Okay, so majorly it is classified as oxidation, combination followed by oxidation, right? Yes, combination plus oxidation, right? Not exothermic, we identify it. We identify it as combination plus oxidation. Yes, exothermic, correct. What's wrong? Correct, exothermic, not just exothermic. It is oxidation, combination, oxidation and exothermic. Okay, next question. The 4 marker questions are here. Are you ready for the 4 marker questions? Let's start. Sarah took 2 ml of dilute NaOH. sodium hydroxide solution in test tube and added 2 drops of phenolphthalein solution to it. The solution turned pink in color. Okay, she added dilute sulfuric acid to the above solution and drop by drop until the solution in the test tube become colorless. 40 drops of sulfuric acid were used for the change in color from pink to colorless. When Sarah added a drop of NaOH to the solution, the color changed back to pink again. This is titration, right? Sarah now tried the activity with different volumes of sodium hydroxide and recorded her observation in the following table. So firstly, you should know from this, reading this, you should know 2 things, that phenolphthalein is an indicator which is colorless in acidic medium. If it is present in acidic medium, it is colorless, and in basic medium, it is pink colored. What was happening here? What was exactly happening here? There was a neutralization reaction between sodium hydroxide and sulfuric acid. There was a neutralization. When neutralization happened, what happened? Salt. We get salt, right? Let's focus on the question. Some things you should already, observe when you are reading the question. You should have some data clear in your head, right? And it is also written that 40 drops of dilute sulfuric acid were required. 40 drops, right? So if you had 2 ml, 20 drops were required. 3 ml, 30 drops. 4 ml, 40 drops. So means for every single 1 ml, let's say 1 ml if we needed 10 drops. So it is the 10 times. 10 times the drops of sulfuric acid required are 10 times the volume of sodium hydroxide given. Clear? Yes, base pink. Yes. Okay. Now let's move on to the question. If Sarah used concentrated sulfuric acid in place of dilute sulfuric acid, how many drops will be required for the change in color? So one more thing there, my dear students, there was dilute sulfuric acid. The sulfuric acid that we used was dilute, and that's why 40 drops were required to bring the change in color. 40 drops were required to bring the change in color. Okay, if we are using concentrated sulfuric acid, do we need 40 drops then? Do we need the 40 drops then? No. Obviously, if it is highly concentrated, yes, 1 ml till 10 drop. Yes, correct. Okay, so if we are using concentrated sulfuric acid, we will need surely less than 40 drops. Why? Because it is highly concentrated. There are so many H positive ion. It will neutralize it fast. So we will need less than 40 ml. It is a common sense question. If you are using dilute, you need much more amount. If you are using concentrated, you need only small amount. Clear? Okay. Sarah measured 20 drops of dilute sulfuric acid and found its volume to be 1 ml. So 20 drops equals to 1 ml. Remember this, 20 drops equal to 1 ml. If Sarah observed change in color of NaOH solution by using 3 ml, how many ml of NaOH did she add to the test tube initially? So 20 drops means 1 ml. She added how much? 3 ml. She added 3 ml of sulfuric acid. So that means how many drops? 3 ml means 60 drops. 60 drops. And we know that 1 ml means 10 drops. So if we have 60 drops, let's reverse it actually. Let's write it that way. If 10 drops equal to 1 ml, clear? So 60 drops will be equal to how much ml of 6 ml? Clear? I am not ignoring anyone. What did I ignore? I told you I'll explain the question in the end. I remember your doubt. Man with art. 60 drops. Yes. So we need to find out how many ml of NaOH they should add to the test tube initially. So Sarah measured 20 drops and found its volume 1 ml, right? She added 3 ml. So for 3 ml, how much base was there? So 3 ml was 60 drops, and we know the drop calculation, right? In the previous table it is given 20 drops 2 ml, 30 drops 3 ml, 60 drops 6 ml. 60 drops, 6 ml, right? Simple. 6 ml, right? The question is, or Sarah takes 10 drops of dilute sulfuric acid in test tubes and add 2 drops of phenolphthalein solution to it. Then she adds NaOH solution dropwise, observes change in color after adding 20 drops. What change in color would she observe and why? So after she added 20 drops, 10 drops of sodium sulfuric acid is there. Okay, she added 2 drops of phenolphthalein. If she added 20 drops, so she had sulfuric acid, right? Initially it was neutralizing, so there will be no change in color. If the amount of sulfuric acid and the amount of sodium hydroxide is equal, there will be no change in color. All will get neutralized. But if you add more of sodium hydroxide, 20 drops she added, right? How much she added? Actually 20 drops she added. So if she added 20 drops, that means the neutralization has gone par, right? It has crossed the neutralization limit. Now it is basic. The color change is pink color. The color will change from colorless to pink. The color will change from colorless to pink. Colorless to pink. Clear? Initially it will be colorless because phenolphthalein in acidic medium is colorless. But when you add bases to phenolphthalein, it gets converted into pink color. Hi. Okay, you're from Kerala. Hi. So Sharma ji, that depends. This one was actually very easy. It was moderate level, so it will come little around it. Actually you can go plus minus, but it comes plus only, a little harder than the sample paper. Hello. Pink due to excess of base. Yes, pink. Hi, Ankur. Hi, Pitti. What's your name? Deep Pitti. Petty or Pitti? I'm sorry if I pronounce it wrong. Next question. Write a balanced chemical equation for the reaction taking place in the above experiment. Now we had sodium hydroxide and sulfuric acid. What is the reaction? We will get sodium sulfate plus water. Salt plus water. An acid base combines to give salt and water. Clear? This is balanced? Yes, this is balanced. 4, 5, 6. No, it is not balanced. 4, 5. No. 4, 5, 6. 4, 5, 6. Okay. Which of the following is true and why? The reaction is neutralization. Yes, this is the neutralization reaction. And what is happening? Double displacement. Yes, neutralization and double displacement, because sodium sulfate is not a PPT, it is not insoluble, it is soluble only. Clear? Okay. Yes, it is very important to solve sample papers of the last 5 years and previous year question papers of the last 10 years, but that is more than enough. Yes, I do not worry. I have some questions for you. Do not worry. Yes, question might come from it. So you need to solve the last 5 year sample papers. Plus the sample paper that are given to you by your schools, that is also more than enough. Okay. So this is the equation. So tell me the answer. This is an MCQ. What kind of reaction is this? Neutralization, double displacement, neutralization, precipitation, neutralization, double displacement, precipitation. There is no precipitation, first of all. There is no precipitation. There is neutralization. And there is double displacement. As you can see, there is an exchange of ions between the reactants. So the correct answer is option number A. Option A. Please bring some questions you want. Do not worry, I have a video about balancing the chemical equations. There I've given you the homework. Please go check it out, okay? It is a different video, different concept, okay? Let's finish this sample paper first, then we have some doubts. Yes, neutralization and double displacement. D. Why D? It is A. There is no precipitation happening. There is no precipitation happening. It is only neutralization and double displacement. Yes, you have to solve board papers. Now, moving on to the 5 markers. Attempt any of these. So, the question is hydrocarbon with the formula, a hydrocarbon with the formula CXHY undergoes complete combustion as shown in the following question. As shown in the following question. Okay. This is the combustion reaction. Clear? What are the values of X and Y? Balance it. Man with that, balance it. I am waiting for your answers. Okay, I'll wait. Just balance this reaction. What are the values of X and Y? Then write the chemical name of the hydrocarbon of this hydrocarbon and draw its electron dot structure. Draw its electron dot structure. So balance it. What is the value of X and Y? See. Okay, see X and Y. So let's calculate the number of carbon on the product side so that we know, we have the idea how many carbons are there in the reactant side. So let's see 6. There are 6 carbons, right? We already have 2X here. We already have 2 here, 2X here, right? So that means what do we multiply it with? 3, right? If we replace X with 3, then we will get 6 carbon on the reactant side, right? Or you can do 2X equals to 6, X will be equal to 3. Clear? What about Y? What about Y? Let's see, number of hydrogens on the product side are 12. So that means 2 times Y equals to 12. 2 times Y equals to 12. Then Y will be equal to what? 6. So Y is equals to 6. Now let's write the formula C3H6. C3H6. So what is it? What is the name of this compound? Yes, 3,4. 3,4? How do you get 3,4? That is not 3,4. That is 3 and 6. Not 3,4 again, Vinod. Wrong. So that is, see, firstly calculate the number on the product side, because on the product side everything is given, right? Calculate the number on the product side. Let's see the carbon. 6 carbons are there. On the reactant side we need 6 carbons. So how many carbons are there? 2X are there. 2 times X, right? So 2X will be equal to, should be equal to 6. So that means X is equals to 3. Similarly, 2Y should be equal to the number of hydrogens that are present here, right? And the number of hydrogens are 12. So 2Y equals to 12, Y equals to 6. Propane, somebody say propine also. This, how is it? The general formula is CnH2n, right? If n is equals to 3, the general formula is CnH2n. Clear? Yes, so how is it propane? It is propene. It is propene. This is the formula of alkenes. This is the general formula of alkene. So the hydrocarbon is propene. The hydrocarbon is propene. Let's draw its electron dot structure. Let's draw it. Okay. So we have 1, 2, 3 carbons, right? And there is one double bond. There is one double bond. Double bond means 2 electrons are getting shared from each atom. 2 electrons are getting shared from each atom. 1, 2, this has 3. This X means the electrons of hydrogen. This X means the electrons of hydrogen, right? So this is the electron dot structure of propene, right? There is a double bond, one double bond, and there is a single bond between the two carbons, right? This is the electron dot structure. Name the alcohol which on heating with concentrated sulfuric acid will produce the above hydrocarbon. Which alcohol? Which alcohol? We know when you have propane and when you heat any alcohol, actually not just propanol, if you heat any alcohol in presence of concentrated sulfuric acid at around 443 Kelvin, the reaction that happens is dehydration. What does dehydration means? Removal of one water molecule. Removal of one water molecule. So what actually happens here? So if you have this is propanol, right? And if you heat it in acidic medium, if you heat it in presence of concentrated sulfuric acid at around 443 Kelvin, one water molecule is lost, OH. Let me highlight the part that is getting lost. OH and one H. The one hydrogen from this second carbon and the OH from this carbon. HOH, which means water molecule got lost. So that means the bond is getting formed in between these two carbons. Clear? CH3, there is CH. Clear? That is propene. Loss of water, done. Loss of water happens. The temperature is in presence of concentrated sulfuric acid at around 443 Kelvin. Write a balanced chemical equation for the reaction of this with hydrogen gas in presence of nickel. In presence of nickel. Let me write the reaction actually. Actually, the reaction will be C3H6. This reaction is catalytic hydrogenation. The reaction is catalytic hydrogenation. And it gets converted, which is propene gets converted into propane. Propene gets converted into propane. There were 6 hydrogens, right? We added 2 more, C3H8. Propene gets converted into propane. That is hydrogenation, or you can say catalytic hydrogenation. This is the balanced equation. This is the balanced chemical equation. Civic sense. Why are you lecturing about civic sense? So carbon is not clear. What is not clear in carbon? Entire chapter not clear, or some topic is not clear? Propane, done. Next question. The electronic structures of 2 atoms are shown. Just focus on these. What is the electronic configuration of P? What is the electronic configuration of P? 2, 1, 2, 3, 4, 5, 6. 6. You can even tell me which element is this. Q, 2, 8, 1. 6. 1, 2, 3, 4, 5, 6. Done. 1, 2, 3, 4, 5, 6, 7, 8. Done. 2, 8, 1. Q is 2, 8, 1. P is 2, 6. P is 2, 6. So what is the name of P? Yeah, oxygen. Yes. And what about Q? 2, 8, 1, 11, sodium. Sodium, right? Let's see the question. Based on the information given above, answer the following question. If P and Q combine to form a compound, what kind of bond will be formed between them? Let me see. 2, 8, 6, right? 6. Why is it 6? 1, 2, 3, 4, 5, 6. Am I doing something? 6, 2, 8, 1. Okay. This is sodium, right? We know that this is oxygen, right? So what kind of bond is formed between them when they combine? Sodium and oxygen combine, we get sodium oxide. We get sodium oxide, and the bond is ionic bond. The bond is ionic bond, not James Bond. It is ionic bond, right? The bond formed by these two is ionic bond. Why? Because, yes, correct, Sharma ji. Because why? Because sodium is a metal, oxygen is a non-metal, and whenever there are metals and non-metals, that kind of bond formed is metal, and non-metal always form ionic bond. And non-metal and non-metals form covalent bond. Non-metals and non-metals, it is covalent bond. Electronic configuration. What is not clear about electronic configuration? 2, 8, 18. 2, 8, 8, 18. Stop spamming like that, Manish. That is no manner. That's not a way to speak in class. Let me just... Hold on a second. There is no, you don't have periodic table for the 10th standard, so do not worry. Why are you worried about that? Don't worry about the a periodic table. It is in the 11th standard, not in 10th. It has been removed from your syllabus. The compound so formed is dissolved in water. Is the resultant solution acidic or basic? Sodium oxide, when dissolved in water, when sodium oxide is dissolved in water, what kind of what kind of solution will we get? What kind of solution will we get? Yes, we will get a basic solution. Because when you dissolve this in water, what do we get? We get sodium hydroxide, which is basic. Write the chemical equation for the reaction between Q and ethanol. So simple, we know that whenever Q, what is Q? Q is sodium oxide. No, Q is sodium actually, not sodium oxide. When sodium reacts with ethanol, C2H5OH, what do we get? Sodium ethoxide. Right? This is sodium ethoxide. This is what we get. Now this is Q. So in place of Na, we will write Q. So the product that we will be getting is C2H5OQ. That is the product that we will get. This is the chemical equation. So in place of Na, write Q, and Q plus C2H5OH, which is ethanol, we will get C2H5OQ. Hi Sagar. Yes. Ethanol. Next is, what will be the formula of the compound formed when P undergoes bonding with a carbon? So whenever formula you need to tell me, okay? Oxygen combines with carbon, we get carbon dioxide, right? Oxygen combines with carbon, we get carbon dioxide. So in place of O, we are using the word P. So replace it with P, CP2. The oxide formed, or the compound formed will be CP2. The compound formed will be CP2. Hi Dev, hi Sagar, hi again, it's a hi session again, hi NK. Next question, Oxygen can combine with both metals and non-metals. It combines with calcium to form calcium oxide, with carbon to form carbon dioxide. What type of bond is formed between carbon and oxygen? What type of bond is formed between carbon and oxygen? This is sample paper. We are solving the sample paper, the official sample paper for the 2025-26 session. Okay. That is a different reaction. That is with ethanoic acid. There was no ethanoic acid there. There was ethanol. So oxygen combines with both metals and non-metals, right? Oxygen combines with carbon. Calcium give calcium oxide. Carbon give carbon dioxide. What type of bond is formed between carbon and oxygen? So we know in carbon dioxide the bond is covalent bond. This bond is covalent bond. Why? Because carbon only forms covalent bond. Carbon only forms covalent bond. So the bond formed is covalent bond. Identify the type of bond formed between calcium and oxygen. In between calcium and oxygen, there is a difference. Calcium is a metal, oxygen is a non-metal, and in between a metal and a non-metal, the type of bond is always ionic. The type of bond is always ionic bond. Clear? Yes, covalent bond. Correct. I am not ignoring anyone. Okay. Next question, which of the above compounds will be a good conductor of electricity in molten state and why? So for conduction of electricity, again my dear kids, you need ions or electrons, right? So when carbon dioxide, in between carbon dioxide and calcium oxide, which is ionic, calcium oxide, right? So it has the ions, so it will conduct the electricity. So just give me a minute, there has been an issue. I think it is clear now. Okay, so the compound that will be a good conductor of electricity is calcium oxide. Comment on the physical state of calcium oxide, carbon dioxide. Carbon dioxide is a gas, calcium oxide is solid. This is solid, this is a gas. What is the valency of carbon in carbon dioxide? The valency is 4. Again, it is forming 4 bonds, so the valency is 4. Clear? If it is, valency is the combining capacity, how many elements it is forming bond with. So it is forming bond with 4, it is forming 4 bonds, so that's why the valency is 4. Okay. Next question. No, actually we are done. Before ending it, I wanted to explain electrolytic refining. Okay, some students had a doubt about it, so let me explain it. Electrolytic refining. It is used for metals which are lying from moderate to low reactivity. It is used for refining, purifying these metals, right, which are from moderate to low reactivity. For example, zinc, copper, right? So you have the already impure metal, okay, not ore exactly, you have the impure metal of these metals, right, impure metal rod of these metals, and you want to get the pure metal, refining those impure metals. So what do? We take one anode, again the impure metal rod that we want to pure it. sorry again, the impure metal rod that we want to refine as the anode, and the pure metal rod is taken as the cathode. And we connect it to a source of electricity. A salt solution is taken as the electrolyte. Salt solution of that metal, of the metal, is taken as the electrolyte. Now what happens exactly when you pass electricity through it? This impure metal rod will start to break, and the metal will dissolve in this salt solution, right? From this salt solution, an equivalent amount of metal will deposit on the cathode. With the time, this will disintegrate and this will become thicker with the pure metal, right? And any impurities that was there will deposit here below the anode rod, and that's what we called anode mud. Simple. There is an anode, there is a cathode, impure metal rod as the anode, pure metal rod as the cathode, pass electricity through it. What will happen? Impure metal rod will start breaking. It will dissolve in this solution. What is the solution? This electrolyte is the salt solution of that particular metal. It will dissolve in that salt. Solution. From the salt solution, an equivalent amount of metal will deposit on the cathode. With time, this will disintegrate or vanish, and on the cathode you will get the pure metal, and that's how you refine it. I hope your doubt is clear, and yeah, that was it. We solved the sample paper 1, and I hope you guys enjoyed it. If you liked it, give this video a like and subscribe to the channel. Take care. Bye bye. Any other doubt you have, do mention in the comment section. I'll look after it. And yeah, you didn't get it. What you did not get, Ashwini? What you did not get, tell me. I explained it very well. There's an anode, there's a cathode. You are using it for refining. You need to remember it. I can't help with the remembering process. You need to remember it yourself. Okay. Impure metal rod anode, pure metal rod cathode. You pass the electricity through it. The anode will break down, and equivalent amount of metal will deposit from the salt solution to the cathode. Okay. Hello, Ritesh. The class ended. Take care. Bye bye.